Okay, hello everyone. Today we want to talk about how do the direct evaporative cooler works. Okay, let's move it on to the next slide. This is a very exciting topic. So what we'll include for these lectures, what are the direct evaporative coolers? How do the direct evaporative coolers work? And then number two, where to install this evaporative cooler? And how number three, how to install this evaporative coolers? And then what discipline need to be get involved for this? Uh, and number four is how to size the direct evaporative coolers. Okay, let's get started first. So you can see the below photos that direct evaporated cooler are installed on top of the roof. Evaporated coolers, normally we know as swamp coolers. So work by using the principle of the evaporated cooling, which means water used for cooling coming contact with the air streams. So it's a direct, so that's called the direct water. So that's called the direct evaporative coolers. Okay, let's move it on to the next slide. So what are the evaporative coolers and then how do this directive evaporative cooler work? As you can see on the left side of the photo in here, the construction of the evaporative cooler is housed in a sheet metal box, and then inside this box, there is a fan that blows the air into the space, into the room or space, and a water reservoir where a recirculated water pump will sit on it. And now you see on right side of the photo, and also you can see the red colored circle. There is a tubing from the pump to spray head above the media pass. So on the okay, apart from that, on another side, on the air intake side, so intakes whenever from the ducting in incoming ducting, and then you can see a red square at the left side of the photo. There is also a float valve, and that float to maintain the water in the reservoirs. And then while as you have a overflow drain is provided for excess water drainage. So let's move it on to the next slide. So where to install these evaporated coolers? You can see on the photo here, we can install on the top of the roof, and then we can install on the wall with a bracket, and then we can install on the ground. So that's a short lecture, a short slide. Okay, how to install these evaporated coolers? So let's talk about the roof mounting evaporated coolers. It has more step, more complicated. And after the system has been sized and selected, a hole will need to be cut in the pinch roof between roof supports, the supply air duct, making sure to seal tightly around the perimeter of the uh, penetration with flushing to avoid any leakage, any leak, water leakage or some air leakage. You can see on the left side of the photo, try to seal tightly for that with all the sealant. And the best location normally is on the back side of the home to avoid the visibility from the front. Next, you can see the top right photos. You will see, normally we will use a crane or hoist to safely hoist evaporated cooler onto the roof, position over the duct. Position over the duct opening so that is lined up with the evaporated cooler button openings, and then install the support leg to add the stability. For the evaporated cooler electrical, so that's also important. You will need to install those 120-volt electrical outlet near the unit and run the wire inside a wall switch or a controller normally. Check your local code as you may also forego the electrical outlet and just run the electrical conduit and wire directly to the switch from the coolers. That sometimes happens. And the controller will allow for low and high speed for fan only options. Also, you may also need a pump on only option that allow you to give time for the pad to absorb the water before sending hot air again. Again, you can see the photos, um, bottom right photos there. You will also need a roof jack where the electrical conduit penetrated the roof. This will ensure you can make a seal to avoid any roof leaks. And that also apply the roof jack also apply for the when you have any penetration. For example, if you install in a tubing, that's another penetration. You also need to put on a roof jack to prevent it, prevent those leakage. Okay, moving on to next, the tubing. For evaporator water tubing, normally a small residential system, I can see a quarter-inch water tube can be used. The tubing will need to be connected to the existing water pipe to provide the cooler with a continuous supply of the waters. So, and the tubing material normally can be installed in copper packs or plastic tubing. Check your local code to see, making sure what's approved material types. It is best to have one continuous length of the tubing in the attic or in a concealed spaces to avoid additional point of leakage where the leak could occurs and water leak will spray everywhere. So it's better to have one continuous one piece tubing for this kind of case and avoiding those of point of connections. And another important point will be a shut-off valve should be provided at a point of connection to main water supply. So that way, if your pipe has some issues, you can isolate those tubings if there's a leak or there's a busting of the pipe or any emergency. And the evaporative cooler for quick access. So in some areas that experience freezing winters, it is good idea to have T connection near the main water source with a drain valve. So in case there is a freezing coming, you can drain the tubing to avoiding busting out there and empty your tubing because there's water inside. Also, you will need the overflow drain connection as you don't want uh, unsightly water stain running down your roof. So you need to get those get those out of your space. Number five, duct locations. So basically, you can install a large opening in a central area, or you can distribute it evenly for those. So for example, if you install a large one opening in a central location in, for example, the hallway, hopefully the evaporative cooler can locate it directly above and make a simple straight uh, duct drop. You can also duct the supply air to each room evenly and then fan out around the ceiling openings and then install the grills. Okay, let's moving on to next one. That's important, very interesting topic. How to size this direct evaporative coolers. So evaporative coolers are rated by the volume of the air that can be provided in unit cubic feet per minute, CFM. Normally people call that. Manufacturer recommend that a certain number of the air change be provided depending on the geographic location of the space. So as a result, the warmer the climate, the greater the number of the air change that will be required. So air change range will from what 20 to over 40 air change per hour. So for example, if there's a 1500 square feet home with the 8-foot ceilings, there will be roughly be about 4000 CFM at 20 air changes per hour, or you can do 8,000 CFN at 40 air change per hour. Also, evaporative coolers use a larger amount of air than the traditional air conditioner that you can imagine for sure. So the duct work is larger to handle the greater CFM. Okay, now you can see the chart here. This is coming from Pacific Gas and Electric, PGC. So have a chart for sizing this energy efficient ducted evaporated cooler for property located in the hot and dry climate, uh, such as California Energy Commission (CEC). Uh, Normally, they will have a specified climate zone 11, 12, or 13, the Central Valleys. And if your home was, let's say, 1250 square feet, it will require a 5,000 CFN unit. You can see from this chart. So you normally go from this square footage of your house, and then if choose if you are hot or the regular one. So the regular one you only have 3 cubic feet per minute per square feet for that, and then but for the hot one you need to 4 cubic feet per minute per square feet for that. So that's a difference here. So this number are based on the 8-foot ceilings. Also, that I mentioned before, you can see that in the zones with an average climate, a design of 3 cubic feet per minute per square feet was used, while a hot, dry climate is designed using 4 cubic feet per minute per square feet. You can consult with the evaporated cooler supplier for the correct size for the applications. So this is about this lecture. I hope you enjoyed. I'll see you in next lecture. Thank you for watching. Bye.